Hello again, thanks for watching this video and studying math with me. This video discusses calculators and approximate numbers. Our tools of choice for this will focus on Excel, the spreadsheet, and the scientific calculator that is available on our campus workstations. Others may be used, but these will be our standards for videos, classroom discussions, and assessments. So students will be required to understand their usage. Most numbers in technical and scientific work are approximate numbers, having been determined by some measurement. Certain other numbers are exact numbers, having been determined by a definition, or a counting process, or a mathematical process. The accuracy of a number refers to the number of significant digits it has. The precision of a number refers to the decimal position of the last significant digits. All non-zero digits are significant, and zeros not used as placeholders for the location of the decimal point are significant. The last significant digit of an approximate number is not exact. It has usually been determined by estimating or rounding off. However, it is not off by more than 1/2 of a unit in its place value. Let's look at a couple of examples of this. Let's talk about the number of significant digits. This zero is just being used to tell you where the decimal point is, so this expression is going to have 3 significant digits. Here, this zero does not help you figure out where the decimal point is, and it wouldn't even be there if it wasn't significant. So this number is going to have 4 significant digits. We also are going to be rounding off, so we have to have some round off rules. The round off rules we're going to use in this class are: if the first digit discarded is 5 or more, we round up. If it's less than 5, round down. Let's do some rounding then with these. We want to round these to 3 significant digits. That means we need to have 3 significant digits. That is 5, so we round up and we have 202. But we have to put that last 0 in because it is used to help us remember where the decimal point is. Here, 3 significant digits is going to be there, but this number then is going to be dropped, and so we're going to have 0.300 as our rounded off answer. We also are going to be using approximate numbers in calculations, and we have rules for that as well. We need conventions in order to do this. So when approximate numbers are added or subtracted, the result is expressed with the precision of the least precise number. When approximate numbers are multiplied or divided, the result is expressed with the accuracy of the least accurate number. Note that these are conservative approaches because we're using least. When the root of an approximate number is found, the result is expressed with the accuracy of the number you're taking the root of, and when approximate numbers and exact numbers are involved, the accuracy of the result is limited only by the approximate numbers. We always wait till the end of the problem to round off to the correct number of significant digits. Let's look at an example. We're going to use Excel to complete this calculation, but let's discuss the significant digits first. The result of this division can only have 4 significant digits because I'm limited by 4 significant digits in the numerator. And we can estimate further that 60 goes into 3,000 50 times, so the precision of this will be to the hundredths place, or sort of like 50.00. But we are adding a number precise only to the tenth position. So our answer can only have an answer accurate to the tenths position. Now let's look at the calculation with Excel. On the left-hand side, you see I put our numbers in, and I am using a formula. When I use a formula in Excel, I will type an equal sign. That's always required. And then I can click on the 40.5, which is in cell D1, to have that number placed there. Plus, these parentheses, and I click in D1, D2, and D3 also, these parentheses aren't required, but I put them here to emphasize that Excel will compute exactly what you tell it to, even if you type it in wrong. The same is true of your calculator. When we do these calculations, we get minus 14.0461, which we round to, minus 14.0, consistent with the previous slide. I did use these round-off tools in Excel to do that, and you should consider doing likewise. Excel is a powerful tool, and you should embrace it. In the context of approximate numbers, a couple more symbols or conventions should be discussed. We use the equal sign, the straight bars, for meaning equals exactly, and also when the results of an approximate number have been properly rounded off. Although the square root of 27.8 is approximately equal to, the squiggly lines, 5.27, we write that it is equal to since it has been properly rounded off. You should make a rough estimate of the result when using a calculator. That may help you not make some mistakes. This happened to me on Friday as I was doing some research. The numbers did not make sense to me. I checked back and I had made an error in programming. In class, we plan to work on several problems from your textbook, but serious students, of course, will want to do more, including reading the section and completing additional work. But for now, remember, time is precious. Each day must count. Do the math. It will make you strong.